everybody, did you miss me? I missed you, certainly. I don't know if everything is working. I had to turn off my PC for 2 weeks. I have still food in my beard, sorry about that. Yeah, I'm back! And I have a tan, a lazy person tan. So, unusual day to stream, but there was like, oh, my hair, so fatty. Okay, greasy hair. Unusual day to stream, but I just returned from, I returned from Costa Rica yesterday. It was a long flight and I wasn't able to stream, and I wasn't able like to talk about openly that I'm going away for 2 weeks because do you announce that you're not at home to all public? I don't know, might be risky. Now I'm back at my comfy home again. Was? Of skiving? What's skiving? What is skiving? Skiving. Never heard that word before. Hey, all the folks. Wait, I need to change the dock here. Ah! Oh! Sonic! Thanks for the sub. I will greet everyone. So, who's there? I will talk about my trip maybe. Hello Tech, hello Adam, hello Mr. Doxing is my name. Hello Ray, hello Johnny, hello Carl, hello. Oh no, not skiving. No. Hey Jody, hello the Sheepu. And do we have everyone? Yeah, and Sonic. Hello, welcome back. Yeah. My father's turning 70 this year, doxing him now. And his wish was to go with all my siblings and me on a holiday for 2 weeks to Costa Rica because he wanted to see it because of the nature and basically the target. It was a nice time to go there, especially because we have freezing temperatures here in Germany. And he was paying for everything. So no YouTuber or pink LED fund was going towards that holiday. I spent a total, I don't know, $150 on stuff that I brought back. I have like Hawaii shirt that I brought with me and some magnets, like some fridge magnets. So basically it was a family trip, and Tony was alone at home unfortunately because it was only my siblings and my father. So you can imagine, I don't know how your family is, maybe my family is very stressful, so I'm not too much rested, but we also saw many things, and we experienced nice stuff there, like animals and nature, and that was nice. I was a little bit surprised about the development of Costa Rica. I was imagining, hey, hype train, hey Christian, thank you for the sub. One colleague is in Costa Rica. Hype train started. Thank you for the hype train. So so Costa Rica is quite expensive. It's like the groceries are more expensive than here in Germany. And also like accommodation is comparable maybe to US sometimes even. So many US people are going to Costa Rica, as far as I experienced, at least in the West Coast and also on the East Coast sometimes. On the East Coast are more like sometimes the cruise ship people and so on. And I was just wondering, where does the money go? Because it seems it's not like the country would benefit from those pricey things there. Like the tourist prices are I think they're okay because it's a nice country, but the money, I don't know. It seems like the people don't benefit there. Current map bugs? What do you mean, like? Ooh. You mean Gulf of America? Or no. Yeah, the Gulf of Disappointment. Touchy subject. Nah, I don't mind. Don't mind. Agree. So yeah, interesting. We met many Americans there, and the flight back was going through Atlanta, so we had like a stop for 5 hours in Atlanta. And I was also joking, looking out the window from the plane. Oh, look there, Gulf of America. I find this funny, at least for now. So yeah, but I met quite a few Americans that are going there for vacation. It's only a 4 hours flight from the US, so it seems like many Americans are going there, similar to like in Germans are going to Greece or whatever, or Spain. Spain is even shorter trip than 4 hours for us, or maybe Canarian Islands. Yeah, the Canaries. Yeah. Basically that. Yeah, so I saw sloths, so a few sloths that we saw there. I thought the concentration would be higher, like of animals, but this is like the over expectation. It's the same like if you go to a forest here in Germany, you don't see any animals. You have like to have the eyes for that. So one time we took a guide. Any what? Trash pandas? What? Oh yeah, we saw raccoons as well. Yeah, at least one raccoon we saw in one park. So they were not. What's the other? There are like the other animals, the Nasenbären. And in German it's Nasenbären. They're more widespread than raccoons, but we saw a raccoon as well. We found four snakes. One was venomous, like a viper, and at least one was. Quite a few are venomous there, but there were not like big ones. We didn't see any anaconda or whatever, but we saw some crocodiles. We took a canoe tour through the mangroves, and we took a guide with us, and we were seeing nothing, and all of the time the guy was, oh look there's this bird. And we're, huh? What is there? I don't see anything. Just we need to stare like for a minute to see the. We saw a caiman, but that was like in a rescue center. So I might talk about that. Waschbär. Yeah. Good day. And yeah, crocodiles were quite hidden, except for one crocodile bridge, which is quite famous, and the people basically tourists throw chicken or meat down there, so they're like in this area, and they are big. Like on this crocodile bridge, they have been big. In the mangroves, we saw one that was like maybe 2.5 meters long, and one baby crocodile, and I took some pictures, but they were really hidden in the mangroves, so. Not like you would feel like threatened by them, but I know for sure you feel safe until you see the crocodiles, and then you think, oh yeah, maybe I don't put my foot into the water. Vorviter Schwager. So and we went to an animal rescue center. Baby sharks, do. No, we didn't see the baby sharks, but we went on a whale watching tour. We didn't see any whales, but we had like some dolphins, and I was like not very lucky with the turtles, so I didn't see many turtles in in the like the sea turtles, I didn't see any. Regular, yeah, and stingrays. I saw a nice stingray out there on this trip. Dolphins were nice. We had a few that were just going next to our boat, but that's what they always do. Teenage Mutant Hero Turtles, no. That needs good tele, yeah. So yeah, but I wasn't expecting that we will see any whales. If they say like, if even the company that does the trip say the probability is 50%, then you know, okay, the probability is 10% maybe at most. It really depends on the time of the year and so on. And there have been people who saw apparently rumors that in February there were people that saw whales there, but I didn't expect anything, and that we saw like a little bit of a nice it was a nice orientation around the parks there. What surprised me a lot is that a lot of the parks in private property somehow. So there are like a lot of fences in Costa Rica, more like other places that I visited. So there is always like the old national parks. I totally understand that they charge a lot for the entry to maintain the parks. But sometimes it feels like, yeah, they're like private property, and I don't know, the money is going there and not to maintain everything. So the entry, the lowest entry we paid for a park was 0 with a donation. Then we had like $15 for an entry for a park in La Fortuna, which was all right because we saw like there was like a more or less like a street, a paved road where all the tourists were going, and there was like a side road through the jungle where we saw all the monkeys and snake and butterflies and like a lot of animals. We saw like off-road, not off-road, but like through the jungle, and that was really nice. That was only like $15, but we also paid like $40 for Manuel Antonio was like, was it $40? Something around that. I saw a few animals there, but it was very touristy, like a paved road through the jungle to a beach, and then you had a restaurant in the middle of that. And yeah, there were some monkeys and so on, but I didn't like it as much. I like a more wild. So that was that. And yeah, I tried to learn surfing like on waves, but I had only like 2 days, so I didn't manage to like balance it quite well. Yeah, that was that. But what about here? What did I miss for the time that I was gone? Seems not to be. I didn't get a tan, so it's not much of a tan that I got. So it seems not to miss anything here. Are there any new advances in technology that I have to know of? Is there anything about Bamboo Lab drama, relative like changes there on the firmware side or whatever? Nothing. It's not like I've been gone for half a year. Silence. Hackaday Europe in a month. Oh yeah, I still didn't book. Good that you remind me of that. I still didn't book anything. I will just YOLO it and go there. Yeah. The Shippo, are you coming? I hope you are coming. Are you coming like day early, of course. Are you staying just for the 2 nights, or how long are you staying? Doxing yourself right now. Sonic, are you coming to Hackaday Europe? Did you book it? I know I tried to convince you. Oh, Jordy, you can't go. Too bad. Yeah, we'll go for sure. I need to book the train tickets before it's too late. Well, that was quite late with announcing it. Yeah. And I missed like by one day the cheap ticket. All right, all right. Yeah, I think like there is one hotel which is close by, which is quite expensive. The pink one, the pink hotel. The hostel is already like quite expensive for the quality. I mean, with shared bathrooms. I don't know if I will take that. If everything goes wrong, I will take the hostel close by just for the sake of it. But there is also like an S-Bahn as train station that's not far away, so you could basically take any accommodation that's close to the train station that goes there, like to the trains that are going next to it. So it's not that bad. I mean, it's only one. Treptower Park. Let me check. Yeah, I think it might be that. Let me check that so I don't. So what I know that. Yeah, it's Berlin, Hecate Berlin. Carl, are you going to Berlin? The entry fee is quite high right now. It's 150 or something. Share your room. Homaris, what is Homaris? Is this the pink one? Let me check. Homaris. What is that? Okay, let me check. I don't mind. It's across this. Oh, that one. Yeah, I would pay my share. No worries. I don't mind. Are you snoring? Probably. We are old farts. Oh, what is that? A nice cat. Christian, did you unlock that? You snore? I mean, I shared a room with my dad for 2 weeks, and he was snoring, so I wouldn't mind. I will check. I mean, I don't stress it so much. Where's the pink hotel? What is the shit? I forgot what the Homaris. Come on, not the roads or. A recording studio. Oh, are you? Oh, okay. Hey, Fu. Homaris. Is this West Side? Homaris. No. Boxy Studios? No. Where is this? Yeah, that must be it. Yeah. Okay. Yeah, I see it. So maybe I share it. If it doesn't dox myself. Okay. So now there's a lot of housekeeping, huh? Okay, booking. So I think it was here, and is this that? Spree. I think this is the bridge, isn't? No. No, wait, that's not the one. Is it the one? Where are we? What is this? No, that's not that one. East side. Yeah, that's the one. So this is the bridge, and I think Hackaday is somewhere here. Oh, where is it? Somewhere here, is it? Huh? No, is it here somewhere? Where was it? Oh wow, it's quite hot inside. It seems to be always like an not all. I think next to the park. Yeah. What's the name? Motion Lab. Oh yeah. Motion Lab. Motion Lab. Yeah, that's the one. Eh? Here. Yeah, it's here. Next to this park, not this park. Looks so it's here. Yeah. So here, and there is basically Treptower Park is the train station. So if you look at the map, this is the S-Bahn station. There is the target, and if you book like in this hotel, so this is the pink hotel here, pink hotel, which is good. The only good in the area that you can probably book. This is already like quite a walk because you need to go over this bridge and then go over this bridge, and then you're here. So this is quite a walk. So it's the same distance as from the S-Bahn. So you can take any place where the S-Bahn goes. Love Hotel, yeah. So I'm not very stressed about the accommodation there. I will like look last minute. Thanks Jishipo for the offer. or do you looking actively for a roommate? I mean, Sonic's still there, but Sonic probably has friends. Not doxing anything. Yeah. Anyways, I'm going. I will be there. I think like the tickets are not limited to that. Doesn't look like I will book one now because I missed the early bird thing. Just alone in it. All right. Nice. Okay, so this is the Hackaday Berlin thing. I will take care of that because now I'm back and my head is free for new stuff. But I also, before we do any other things, or before we get distracted with other stuff, let's do some work. So I was thinking, someone contacted me about on Discord, hey Wagon Loads, you're just in time for today's topic to be started, because we did only like our 2 weeks recap of my vacation, more or less. I can share pictures maybe next time from Costa Rica, but I only had my broken Pixel phone with me. Even with I even dropped, like days before, I dropped it on the floor and my screen cracked again. I already exchanged it 3 times. So I certainly wanted a new phone. And then I thought, okay, I will destroy it for sure on the vacation because I'm going outdoors and whatnot. So I kept like this Pixel 3a for the vacation. And it made all right pictures. Sometimes my sister, my little... Get one without the screen. Yeah, or like I mean, I have like this the old Sony ones with plastic screen or like plastic cover on the... Anyways, yeah, no screen, or maybe like e-ink displays, or there's also glass. E-ink displays, they have like this surface looks like, or like the e-reader displays, they look like they're not glass. Spider robot that rolls on hoverboard wheels. Yeah, you have to ask the Shippo for that, wagon loads. Glass or plastic. Yeah, that would be nice, like fast new ones with plastic foam. I probably no, I'm using my phone to watch stuff all the time. I don't know, maybe a foldable phone with e-ink outside and inside a tablet with a foldable, but then I will also like take dirt in the center and then break it anyways. Hey Kaspar, nice. Welcome back. So we were talking about Hackaday Berlin and my vacation, and now the topic, a portable beamer. Yeah, I have this one. This one here. Here, portable projector, and it's not even like very dark. And I bought it like years ago from AliExpress for $100. Aoun, yeah, it is all right. It says even battery for like 1 hour. So you can, or they say it's 90 minutes, but you wouldn't be able to watch a movie on that. Just project the image on your belly. Yeah, yeah. But I have many molds, like, so there are always like dead pixels, dark dead pixels on my belly. You can use your broken phone as a hotspot for a flying robot. Teletubby, yeah. Okay, so I was contacted by someone asking details about my RISC-V supercluster. And I thought, I did a few things wrong on the supercluster. And now with the QFN package style, and like, I don't know, things that I learned. I hope I learned something. I can't remember. Maybe we can design a new supercluster that we can manufacture like by JLC or whatever. That's easier to make. I don't know. What do you think? And I would totally like to do something with PCBs again. 207. Is this a new chip? $208. What did I use? Which one did I use? 209? No, 203 and... What are the specs? Let's check that. So, you know, my older design was like 203s that were managing... Oh. So it's quite fast. Isn't that fast as well then? CH32V208. I think I used, yeah, that's the one that I used as well for my WCH page is down. I think I used those for my, let me check. These is the ones that I used for my magnet tiles, didn't I? The ones with the screen. Where are my magnet tiles? Do I have them here? My greasy hair is really... This was using the 203. I don't use the DLE stacks. Which one did I use? Damn, we can find out. website says no. Yeah, that concludes the stream. You have more than 30 PCBs in design. Does it use the NIM BLE stack? I have no clue. So this is the question that Dushipo has to answer to. So my idea, oh, look at that. What is this? I just found this on my desk. This is one of the boxes with the chips, but there is no chip inside. I thought I had it here. Let me check if it's inside of. No. Oh, yeah, here it is. There it is. Let me check. I like that one because it has also the USB. That's what I picked it that time. Let me check in the microscope because I can't figure out, or I take my phone. Yes, 208 was what I was using. So this is the one that you took. It has even more than 64 kilobytes, does it? I thought it was more. So I used it for that one, and the package is also nice with many pins, and there are many groups of 8 pins, I think. Let me pick up, I might. Ethernet, yes. I don't know what kind of firmware was implemented before that, but let me check my dev area. PCB, RISC-V. Oh. Datasheet. Yeah, that's the QFN. I also like QFN more. That's what we are doing. So is this? Here we go. Here are the specs. F8. Here. So yeah, you're right. Strange. The 2.7 has more flash, more stuff, but you have USB. There is the host device, so you have USB host. That's also one thing that I liked about it. That's why I put no. Opa BLE, you're right. And Ethernet, there you are. Can't you put a firmware so it prints version at startup? Hey Tech. So it's only 64. The price is still quite high. I let me check the 12-bit deck, Chris. Oh wait, Sonic, did you try like a new deck? Was it working better? Did you try to do more stuff with the laser? Let's start from ground up so I can learn with you. Yeah, I'm so much finer details. Oh really? But you didn't need to amplify it? Oh really? All right. Okay. So you have been doing some work here. Nice. So Are you able, like the DAC, is it able to do like plus minus, or is it also like 3 volts output? Still, yeah, I know, that's why I'm asking. Oh, 4.1. Okay. Yeah. All right. I mean, that's more detail. 25 for me. Yeah, 25% squared, because in both directions. Yeah. I think I can maybe dox myself. Let me check if I can dox myself on the Q, on the LCSC, because this is also. Oh, all right. Let me check my orders. I hope it doesn't dox me. Yeah. Here you go. This was here. There it is. $100. Let me check the details of the order. Oh no, I had other chips as well. Opala, not that one. That one. Here we go. So I paid 126. Yeah. Oh, what the cheapo. Order quantity 20. I paid 126 for them. Did they change, or is it more expensive, or is it? Oh shit, they got more expensive. Wait, what? They increased the price substantially. That's like 20% up. Ah, probably because the firmware is more advanced right now, and you have like this Bluetooth support and whatnot. Do you have a reference board with the Bluetooth? I can dox my username. That is mean that they increased the price, so there's more interest. Yeah. Probably before it was like subsidized, and now they're having any profit at all. Yeah, so I used those before. I was just wondering if I missed any developments on the WCH on the. There is like one that's Trumpian tax, but that's not applicable for European orders. I'm not affected by Trump like tariffs. At least not like maybe on BYD cars, but not. Charles is still hard at work. I don't know. Interface, no. Where is the development boards, tools, kits, circuit, ESD, microcontrollers? Okay, so 0. Yeah, that's the. I have stock here. I still have stock on those, I think, at JLC. I have to check. Let me check on JLC if I have stock on those. I might have all JLC. So maybe I will discuss. Maya, you know Maya. He did a nice project with this I2C of the PCI Express extension port. And I'm wondering if I can do an extension card for the supercluster that is communicating with that I2C interface. I don't know what's called again, but I found it quite interesting. So accept essential cookies, parts manager, my part library. Okay, let's check. JLC parts. Okay, what do I have? Here. No. Wait. Do I have 430 of those? No. Wait, no. What is my stock? Did I use any of those? No, this is not my stock. Wait. What is my stock? Did my stock expire or is this my stock? I wouldn't be having that many. Would I? No. How do I see my stock? Order, file, parts, order parts. My lists. So 21K LEDs, yeah. No, I don't think it is. No, it's not my stock. But how do I see my stock? My parts library. My inventory. Here. Huh? It looks like. I might have spent some cash on the LEDs though. Because I made like the mini game, the one with the Megaplex. I don't know. I see. Yeah, these. I know that I had to take some of those because they're the 3.3 or 3.2 volts LEDs that I didn't need, like the ones that are emitting UV light. The handheld ones. And I thought each time I need like 200 LEDs or what's on the display. So if I want to manufacture 100 devices, then I need 20,000 LEDs. It is what it is. There is no, this is the math. You need 2,000 LEDs to manufacture like 100 Charlie Plexed mini games. So there's my investment, and I still have 430 of those. Is this true? No. That would be like, yeah, they have more of those on stock. So if you ask them for, oh wait, no. If you ask them for them, they have like 6,000 in stock. And they are also increased in price. 16 cent. I'm confused. AJ35. Where's the 0.5? Where is the small one with the USB? 1.3? Speculate on them, yeah. But I don't think I can get my stock out of JC. Like I can't make them send them to me, or can I? Bitcoins or gold? Yeah, that's pure gold. I see. Next chip shortage. I'm a scalper. Chip shortage scalper. Condemn me. This is the one. They have only 33 in stock. What? This is the much cooler device, but it's also like short seller. 10 cents more just for the USB. Damn it. They got quite expensive as well. They hooked us on the nice ICs, and now they're trying to skim numbers. Boards on it. Can I hire a PCB house to work as a reseller of my designs, so I don't have to pay for boards unless they have a buyer? Wagon loads. You need like maker fabs. You can let them make, but you have like to pay in advance for like 100 pieces, and then they can use whatever they sell for like the next batch or whatever. So this is, I think for sure that works with maker fabs, but you have to pay in advance. Otherwise, I don't know if there is, because it would be like Groupons or whatever, where like or crowd selling. There is like they are. I think there are platforms where you can basically get the money for one. What was the platform? There was one crowdfunding platform where you would get the money for the manufacturing. It's not PCB. Oh, can you do that with PCBWay just for a share? That you give them the design and they will just manufacture it, send it out, and you get a share? Because there's certainly a difference if you let them make like 100 pieces or 1,000 pieces or one piece. And there is a substantial difference in cost. I'm not very experienced with that. My only experience was letting bots manufacture, send it to me so I can do the quality control and then send them out. But Brian did it like with Maker Fabs, that he let them produce it, pack it, and send it. And he was just... That is what you mean? Yeah. Yeah, so basically fulfillment center, manufacturing and fulfillment center, you can do this with Maker Fabs. And I think Seed would also do it. Seed with 3 E's. Do the certification. Yes, I mean, if it's a kit, you don't need the certification. If it's like dev board or whatever, I don't think you need a lot of certification there. I'm not sure. It's a different thing. Like Xeon has to do the certification because it's like the radio device. The modules, the ESP modules, they have already certification for the module, but certainly not for like the whole part. So if you deliver it with case, you certainly need the certification because it's a finished product. If you sell them as a dev board, I don't know. It's a gray zone. I can't tell you details about that. I didn't sell many. That was like always a collector's item or whatever so far. MyMax. Yeah, Maya is obsessed. Maya is obsessed with certification and legal stuff, so you have to ask him, or do the what's this salamander? I don't know, Samlanda things. Didn't he want to do this? Self-certify. Yes. Yeah, you can always like add a letter of conformity or a statement of conformity if you want to sell in Europe. That's CE, FCC, and I think it's a conformity statement. So there are like some requirements for products that you need like to guarantee that it's doing what it's doing and not exceeding any, harming anything, and doing bad stuff like radio jamming or whatever. And then you will basically insure it. If someone sues you, oh yeah, allegedly. I mean, what does the self-certifying do? You just tell, okay, I ensure that it's doing what it's supposed to do, and if it not, I'm I don't know. If I don't know, it's a gray area, I think. I'm not experienced. Smander. Yeah, Smander. Thank you, Johnny. You're in trouble. Yeah, if it's not conform with, you might get sued. Yeah, so you better put like some company in between you and your product. Certificate, yes, because if you don't change the properties of the radio, but properties of the radio are always changed, but they are usually not amplified, so you basically, they might get like jammed by, like, if you put it in the metal case, you certainly get like worse radio for you and worse noise, or like lower noise for everyone. There is like certainly requirements for noise on the power lines as well. There are certainly experts in the chat. Yeah, original firmware not using Wi-Fi. So if you send it blank, then say it's a blinking device. You sell it as a blinking device with the blinking sketch, and then if someone uploads a new firmware, they are responsible for it. Superhouse? Certainly. I don't know if it's how viable it is. Like if you're they can only Tangera MP3 player didn't need to do Wi-Fi certification, even though it does use ESP32. Oh yeah, if it's like the final product and it's not intended to be used like that, then certainly. I mean, the company, a company that manufactures like JLC PCB is also not certifying PCB antennas. That's how I see it. If you use a trace as a PCB antenna, that's on you at the end, not on JLC or PCB way. Okay, CH33. Oh, what is this now? 33, 35. What's the difference between 33 and 35? Except it's the same price. Why would you buy the 33? Yeah, certainly. A lot of computational power. I mean, you can use the Raspberry thing as well, but I liked it because of the loads of RAM and power. And formerly the DACs, now they're gone. We are screwed. They screwed us over. 32 cents for the big one. 35, but there is a one with F8, G8. Oh, what's the difference between those? Except this stock is better. Let me check. 35, 33. They removed the DAC since the first version. Like S2, S3, no DACs anymore. No DACs, not DACs. Like there was never a rubber ducky included. Oh wait, huh? Wait, where is it? Huh? Wait, it was wrong. What I did was wrong. Is this the one? Yeah. Okay, V4C. Okay, wait. What's the difference? Let's check. Yeah, sigma delta, but sigma delta is not the DAC. EMC testing. Yeah, there was like a power issue, wasn't it? Yeah. Like the power line was too noisy on the USB or something. Or what was the issue? How do I remove that part? Can I close it? Can't close it. So that sucks here. Oh, no, I can close it. Okay, here we go. The difference between 30, that's 35. But what is 33? Where is the 33 version? What's the, oh, there. Okay, difference. The difference is host device, type C source things DRP. What is DRP again? Type C. That's like the where you connect the 5.1K. You need it for the. You can probably use like the power delivery. Derp. Yeah. What's the pin count? Nee, that's ADC. OPA, CMP, comparators. Okay, you have like one less comparator. G8U6. I think this is the one that I used. Capacitive touch key. QFN28. Yeah, I would use only QFN. Oh, that's like large quad flatback. Quad flatbacks, forget about that. That's the TSOP. Yeah, there is no way I will be using that. There's like, why do we pick on difference of 5 cents if in the end you produce like 5 pieces? You saved up 20 cents in total for your whole project. Just for the potential that it can go viral. I think optimizing first is a bad decision. Comfort first. Should we use Raspberry Pis instead? X-ray cost if use. Oh, you mean JAC or LCAC? No, you mean JAC. Really? No. QFN? No, you're kidding me. Are you kidding me? Since when? I mean JAC and X-ray cost. Oh, really? Oh, let me check that. Is this new? They did it, or did you had like? Maybe you had like what's the other? Yeah, maybe. What's the other thing? The with the soda balls. The Brzęścikiewicz. $8. Yeah, okay. I usually ignore that. But I was wondering, let me check if I got them in my last orders. Order history. Let me check on my assembly because I used assemblies. Here we go. Merchandise. It doesn't show details. Product details, economic PCBA. Grzegorz Brzęścikiewicz. Yeah. No, I don't see all the costs, unfortunately. Order details. Here. I hope I don't dox myself. Here we did. This is the 32 version, QFN version. that I didn't use at the end. I mean, we still have those. We didn't do anything with those. And assembly product details. That doesn't show bill of material part placement. Doesn't show anything. Oh, come on. My parts. Maybe. I don't know. Now it's zoomed in. Here we go. What is this? What is this price? Special price for bitluni. Oh, I have different prices here. Merchandise total. This was without. I have only 20 pieces, $310. If you're wondering why I sold them for like, it was like even cheap. I think $30 or $25 per piece. I had only 25 or no 30 of those. Yeah, this was with coupon. Anyways, like it can go up, and then the €8 extra height. Oh, for a max, nice. Is that the ADC? Is this an ADC? What is that part? Is there a KiCad circuit for the Pi so I can make my own from factory? Oh, amplifier, nice. Wagon loads. The Raspberry Pi designs are all open source. RP2040 design KiCad or reference. Let's see here. There is hardware design for the let's check the license. MIT license, here you go. Was first hit. We just posted for you here, chats. Let's check what kind of, yeah. Basically, there's everything you need. That's RP2040. So let me check. RP2040. Now we have the new one. What's the new one? The RP2040 is, yeah, that's cheap. You could get them for like $1 a piece. Now they're like super on stock. What else do you want? I mean, it's not the fastest chip, but PIOs and so on. What is RP2041? That's like a device. Oh yeah, that's... You can... A wave share? A microcontroller board. Sweet. With I/O. $10, that's crazy. But you can get them for $7. Raspberry Pi. Let's check what else do we get from them. What's the new? Oh yeah. Oh wait, the new ones they support like, or there is a version that has internal flash. What was that? Electronic power adapter, LoRa, RF, Wi-Fi modules, microcontrollers. Okay, let's see. We have Where's the RP2040, RP2350B, 50A? There is, I think there is one with internal flash. There was certainly one with the new version, wasn't it? What is the difference? Is this like the version? But they're out of stock anyways. Let me check that. External. Ah, is this the one? Okay, we don't get the stock on that. That's like 4 MB. Hey, DHC. That's like, where do I get it? Hacker News. Has flash finally. QSBI, so it's not really whatever fast, yeah. Octal SBI. It doesn't look like it's available, is it? Product. Ooh. Okay. It seems we have to use. We are back to WCH. Wait, this is not what I. No, that's a Raspberry Pi. Where is our WCH stuff? I lost it already. Spotty. You don't get all the results. But it didn't look like there's like LCSC or whatever. My claim it's not available. Where is it? Did I close all the windows of the WCH search in LCSC? Anyways, okay, so let's continue. What do we have? Paint.net. The best part about me streaming on Saturday is that the next stream is at least only like a few days to the future. I don't know if I might even give you extra streams, but I need to finish a video as well because there wasn't one for 90 days. Ugh, people are killing me. All right, so how about making a new version without extension cards, like without extension? So what I used was, where's my JC window? Closed it again. Yeah, I closed it. So I have this one with ports on that. Then I have the version. Okay, you can imagine. Oh, that's too much. So I have the one with version 1 was with the headers on the bottom, which were a little bit, since they were surface mount, because of lack of that, we were using, because there were no QFNs, we were using these the packages that causes bridges. Then I did the second version. We had like that was 16 times. That was 32 times. This was using like extension ports and I think it was 8 and extension ports, 8 devices and so on. People were thinking that's not a great design. What we can try to do is a really compact design with, let me draw at least one here. And make it a card. Make it a card. What do you think? Isn't it a great idea? I never did a card before. Oh yes, I did. But I didn't use it. For the C64 extension port, we did a card. JSC can even do like the wedge thing if we want it, because that's extra cost. So the interesting thing about those would be two Soviet apartment buildings in a shed. Yes. I don't know if we want an LED on that. Do we want an LED here? Do we want an LED on that, or we just do without LED and just only we would need maybe we need the 100 nanofarads thing. Magnetic connectors. Pink LEDs. Yeah, but we don't have pink LEDs with, so we need 4 components again. So imagine that our baseboard has only like sockets for the boards, and then you can make a cube with the cards each. What do you think? What does it do? It does nothing. It's the same that the other supercluster did. Nothing. Just blinking LED, maybe. Like IT crowd, like the IT crowd server. It just doesn't blink. No, I mean, the formal, we did a few things wrong. A mini S100 bus system. What is S100 bus system? Some sensor built in. It has an ADC built in. LED via jumper to turn on after initial tests. Yeah, so one thing that I learned is don't use a shared programming pin. So what I would try to do, the issue is how dense can we do the connector? How dense do we want to make the connector here, the slot connector? Would it contain the internet? Yes. Thermistor. Whatever you want to, but I wouldn't like to add anything to the cluster. Everything should be external. S100 boss. I mean, Ooh. Architecture. But why 100? That's like an odd number. Why not 256? No, I did a design for something like that before. But then you need like serial edge connector, I think easiest to buy. I have plenty of 1/10 of an inch connectors here. So yeah. Let me check what connectors I got. Order history. I have like plenty of connectors already here. Let me check that. Order history. Where is an expensive order? View all the details. Oh shit, did I dox myself? Yeah, it's an old address anyway, so. Let me check. Nope. Where is it? Yeah, I know. Here you go. Oh no, this is the old one. Yeah, that's the surface mount thing. Yeah, no, that's why I want a card connector, not a surface mount connector, whatever. Card connectors are evil. So what we have with the CH whatever is like 8 pins that we want to share on the bus, maybe 8 pins, 10 pins extra. Wait, is this 8? Is this 10? No, it's... So there are like 2 ADCs, the A pins, and then we have 8 and 8. Through hole edge connector. Yes, that's what I mean. I have plenty of the through hole edge connectors. I can show you. Like I have the ones. Let me check. Damn it. Hey Fenua, going fabricate own connector, couldn't find a symmetrical 11 pin 1mm pitched one. Oh yeah, that might 11 pin, like an odd number. Pogo pins. Oh wow, I hope, are you doing this on scale? I hope not. This is like a challenge. 11 pin, like, oh yeah, that's... I was surprised to find quite a lot connectors on LCSC. Where is my LCSC thing here? Huh? Did I lose my window again? I lost my LCSC window. Boomalek, yeah, that's my LCSC window. Female headers, connectors, edge connector. Is there like an edge? Edge board connectors. Oh, that's also like DRAM stuff. That's nice. You have like a high density. Going for the beauty price pitch. Is it necessary that you have like 1 mm pitch, or 0.5 mm would be also okay? So you can go twice the density with an off-the-shelf connector or something. Let's filter 1 mm pin pitch. Yeah, there are no options whatsoever for that. Here. 1 mm tray, they don't say anything about that. Let me check that. Oh yeah, no way. You have like this part in between. And it's not 1 mm. Yeah, it's 1 mm typical. This is 1.5 from that separator, and I hate it, like the key. I mean, the key is alright if you don't. Yeah. That's bad. Like, I found a connector without a key and LCSC. Oh, wait, let me show you. So what I was looking for is 254 SMD, no, true hole, push plug in. Is there another one? P254 25 here. Yeah, look at that. This is the ones that I got. So there are actually, if you look for them, there are not keyed ones. And this is what I liked, because you got 2 times 31, and there are certain sizes. Which type is it? Plug in, so we can use, yeah, plug in, so we can remove that one. How do I reset it? 25 plug in 254. Okay, apply. 25 in, and then number of pins. They're always even because you have 2 pins each, 1 pin each side. So the highest is 280 pins. All right. Look at that. Is this? No, they're not available. They're not available in stock. Yeah. They're not available. $120. Yeah. How? Look at that. 120, and it's available. But this will be with key. No, it's not keyed. Look at that. No key. 120 pins. What is this 120 pins total, or is it 60 each side? This is like a huge connector. Pin. There's even like 62. So it's just 2 times 60, I believe. Yeah, it's long. How many inches are those? 0.1 inch times 60. That's like 6 inches. This is 6 inches, isn't it? It's not that big. That joke. That's what she said. That's not that. That joke's here. Half a foot. Yeah, my feet are not that sizable. Aren't they? I don't know. 120 pins. Yeah. More common ones. Do we have like reset the filter and also reset the pitch? Huh? Wait. Can we reset the pitch as well? Oh yeah, here. No worries. Okay, so what I like, I think if you saw that in yourself, the DRAM connectors are probably a good pick because like they're not huge, but you also can't put many of them next to each other if they're not like square. If they are flat, you can get ones that, oh, look at that cutie. Oh, that looks cool. 42. Here we go. This is the right pitch. That's like, yeah, that's 1.227. So maybe, I mean, you save like half the size. What's most common? Let's check. Let's do the right filtering here. We are already optimizing again. Damn it. What's the common? 0.5 millimeter here. That's the DRAM pin pitch. You can see. I will zoom out for you. Here we go. Now you can see. 0.5 horizontal edge board. Yeah, PCI connectors, but PCI 0.5. 0.8 horizontal. I want vertical connectors. Let's check for vertical. Can we do vertical here? Edge slot, band, clamp, indirect, horizontal attachment, standing paste. Yeah. Yeah, I think also. But we might need... Oh, that's also current is... we need a few power pins then. So what I would do is fill up with the GPIOs and the bus, and the rest goes for power. Try to distributing it. Also trying to separate with some grounds. Maybe distribute the no. Do we want to? Yeah. Some ground pins to do some shielding maybe. For the crucial high bandwidth stuff. Maybe the ADCs need to be also separated by a ground line. Uh-oh. Okay, let's check SMD, plug in, bloop. Apply. Stock is terrible. Look at that. What is this? Yeah, no way. Wait, this is maybe the wrong plug in. What else do we have? SMD. Oh wait, what? Oh yeah, these are the stock stuff thingies. SMD. But I don't want. I mean, they can place SMDs. IDC. Yeah. Wait. But how do you? Nah, you can't. Can you? Wait. IDC. Wait, let me check my edge connect for my connectors here. Where are they? Eh? You mean this here? Ah. Like this here? No. Is this what you mean? No. Like that? Yeah, C64 cartridge. Nice. It's similar to DuPont with 3 rows of pins. Oh. So you think instead of cards we should use pins, like right-angled pins? Really, those floppy drives, MFM floppy drives? Look at that. How many pins can we get there? What's the highest pin count? What is this? 100 pins. Ah. That looks nice. You can see it's you can even see it's 7 centimeters. Cool. 7 centimeters. What are 7 centimeters? Oof. Quite substantial already. Yeah. Yeah, that's this size. That's the distance of my pupils. Quite big already. I would like it to be smaller. Oh, I have an idea. How about we trigger people and do only 9s? Turbo channel, alpha works. So make it less pins because when using 9 MCUs on one board. Or even worse, let's use 7 MCUs, like distributed like that. To trigger people, and the board is shaped like that with a connector here. This is already a viral video coming. This is a viral video coming here. The minimum wire you need for a bus. That's a skull board. Yeah, skull board would be something for Halloween. In fritzing, is it possible to make it like angled and whatnot in fritzing? Why fritzing though? What's the benefit, Dishipu? Yeah. Auto wiring, auto routing, auto routed 7 MCUs. We just take, because fritzing design trigger people. I designed it in Blender. Zombie PCBs. Curved for mesh shape PCBs in fritzing. Do you remember the extension board that we made for, I think it was I bought it on Isla. I made this board, the extension board. 3 wheels is the minimum account. Wait, where's my playground? Where is it? I can show it to you here. Here. So this one, it's so if you look closely, you can see it's slightly angled here. So this board was already off, and I didn't notice, I think, even. Or did we notice when we designed it? I have them here still. That is a triggering card. Yeah, but it has labels. Bottom. Lass mich doch mal fliegen. What is das? Bitluni C64. Lass mich doch mal fliegen. Rüdiger. There's only missing. Oh, and this dot, this via is also triggering. Oh, that triggers me somehow. Did it update? Yeah, it's loading. Wait, 0. Reload. Extracting top layer. You can see the distance. Do you see that? If you put it next to this edge, okay, there will be always the same slope, no matter what you do. There's the slope. I don't know, because of the ground pin maybe? I don't know. It's really odd. Odd-shaped card. But we made it. Maybe we put the cluster... Wait a minute. Can we put a cluster on a C64 card? That would be odd. C64 RISC-V cluster? And what do you do then? We'd put the... One side would be programming pins or like a pogo or whatever to program each of the device. A cluster on a C64. But we have the problem that our address space, yeah, we don't have so many bits. We have only 16 bits in total. So what do we do there? Wait. What is the way that we put ROM? We can... Oh no, it's hard. With an RP20, just white, yeah. Machine sharing data bus and clock, yeah. This will be, I think I bought the chips already on LCC, like the interface chips between 5 volts and 3.3 volts. So maybe we can even disable the bus with the address lines. So because we need like to, if we addressing the memory, if we like share memory space, how do we do this even? How do we could, how would this interface work? It's an interesting thought. because we could share we have 16 pins and 2 more for controlling or whatever. So in total we have 18 pins that we can use with the WCH, and we need like the address lines to enable, disable, whatever expansion RAM. That's how that worked on C64. So whatever communication we would have would be mapped with over the address bus, data bus. So we have an 8-bit data bus, and then the address space would be we need like to do some logic to enable each of them, and each of the chips would basically cover a piece of the bus, and we have like 16 kilobytes of memory, so we could use the C64. Yes, it has. You can see it here. Sorry if it's not like here. You have 16 addresses and data. And what we have now is we have basically we can do, where is our WCH data sheet? That's the wrong one. C64 space memory map. Here we go. Here we go. So we have kernel ROM, basic ROM. How was it? Ah, shit. Let me shift this so you can read as well. So this is I/O. You can basically, I think you can map the addresses there. I forgot how it was. We certainly used like the extension card that was we can check here. 0-page, enhanced 0-page, operating system with and basic pointer, screen memory, machine language, reserved for interface extensions, which is not a lot. That was, I think you can remap some of the expansion ports. Wait, ROM table. Cartridge ROM only becomes resident if attached to expansion port on power up. It's included for completeness as a record of the addresses it occupies as a ROM bank. So there are different banks. Cartridge ROM low, basic interpreter, character generator. No. Who is still familiar with that? You can swap out the ROM to, yeah. So what we could do is basically attach a cluster, not doing any bus stuff, but using all the data lines of the CH32 with demuxing a buffer. No, we can demux the address to map the chip, and then use like the other. Okay. That's an interesting thought. We are just rambling all the stream today. So let's extend our ventures into the cluster stuff. But it's an interesting thought. So let's try it. We have limited pins, limited IOs. So we have 2 ports that we can use fast. So we have like 2 pairs of 8, 2 times 8 that we can use fast, and 1 time 2, that's A port, that's think BC or CD, B port B and C, and this is A. Z80 CPU can address, but they're not like, I don't have a Z80 here. That would be cool though. Let's start with the C64. So what we could do is we use 1 for the data pins, the 0 to 7 from the C64. Then we have the address 0, oh wait, sorry, wrong. 1 for the address, a 0 to 7. Then we have like 1 enable. What is enable basically? And 1 pin, I don't know, bank, whatever. I'll check him out. Check. What did he do? C64 expansion parts. Are we spoiling everything? What did Niels do? Let me get the link here. Is there like a interesting project that's similar to what we're trying right now? I'm worried because I want a cool project. Anish is DIY programmer. Okay, I will sub to it. Oh wait, what? Okay, interesting. So let me keep my original thoughts. I don't want to spoil myself. What do we need though? Do we need like write read? Yes, we need write read. Wait, there is like something. Read write. Clock. There. Oh no. Wait, this is read write enable. I don't know. Oh shit. We have not enough pins. We have not enough pins. We need to clock. Bury it, yeah. How do we do tri-states? How do we communicate? Let me check the bus again. Wait. Where is my... I think there is like... Okay. So the issue is right now DMA. Okay, reset RQ. Read write, that's the one. Ah, shit. We certainly need something like, that's hardware interrupt. Reset. Reset doesn't matter. What was BA? Man, I forgot everything we did there. Okay. Bit bang on the 8-bit data bus toggled between peak, read and signal low if address bus is within. Okay, so this was the expansion addressing stuff. Area indicator. External ROM. XROM. So these are relevant for our multiplexing and logic stuff. ROM low. Range switch on XROM and of this address occur on the bus. That's also relevant. Bus available. Bus available, direct memory access. CPU can be requested to release the bus. It will stop after the next read cycle and all bus lines will go high resistance state so other units can use the computer hardware. Okay, so this is just an DMA request, external DMA request, I don't know. Data line, CM buff. Read write. Where's the read write here? High level during read cycle, low level during write cycle. Low level during write cycle. So we would need at least that one be communicated and the clock. So I don't know if this is sufficient. So basically read write on, and how do we enable it then? We don't do clock. So usually we would like no, the problem is yeah, no, it's more than that. So we have like read write. So we know that we either read from the data or write to the data to be correctly reflected, either to move it into the RISC or out, if we like copy the memory, it would act like we can make it act like a read RAM interface, or we just give it like one byte. We don't use any addresses. That would be also right. So we have more pins left. But then it doesn't do anything else except for like clock. And let me check the CH32 reference manual data. No, not the data sheet. I think data sheet might be alright. Let me check if the pins are there. Pin configuration. Here we go. So yeah, that's D. Sorry, D, A, D and C, not B and C. Sorry, that was wrong. C and D. A is oscillator. So PA1, that's oscillator in, oscillator out. So we can actually use an external oscillator as like the clock, which would be way too slow, or we can use it, putting it there is all right. Then we just miss all the stuff, like the ADCs. We can't use that if we need like this as an input output. Then there will be the programming pin, but I think the programming is alright. We can turn it off internally. It will be just on startup. Will be programmable. Like, yeah. So, what I would do is use this as a shared address. So this is the address is shared amongst all the MCUs. Daisy chain the clock. Nah, well, really? Okay, and this will be basically, let's see it like that. I mean, we did similar things with our ASIC designs with this chip, vector chip that we wanted to design before. So if you split it, that would be 0, 0, 0. So we just need a DMAX here. And this is 1, 0. Oh, yeah, breadboard 27. You need a differential signal there, I believe. Breadboard is hard. 1 and 1. Okay, so this is how it would work. This is like multiplexed. So this is like DMAX. Whoops. DMAX without E, it's DMAX. We can just DMAX basically, that would be a read. Do we do the clock? What do we so how do we signal the chip that it's meant to be? So we don't have a chip enable. So we need somehow to data and clock on a dameware. What is dameware? What? So we have here like, let's say 4 pins in, 16 out. Same wire. No, what, yeah, either we then use each like read write to each chip. We can do it with enable as well. So probably we can just wire read write here as an enable or something, maybe. Read write. I don't know. Either this or the clock. So what is write? Read write is write high. So what we could do is basically these would be always in the right state. No, shit. That's not good. No, we need to do the clock. Because read, this is the open drain mode or something. We would need to pull it down. Oh, this is very hard. You need to consider that. So we need either a lot of logic here, like digital logic on that side. Yeah, that's what I mean. We need like, we have only 2 pins. Either that or we just use 127 address points to communicate with the device, and then use 1 clock, 1 read write, and 1 enable pin, which is sad. I would really love to be able to use like 256 for shared memory of, not shared memory, just mapped memory of 125. What's the block size of the RAM that we can do? Oh no, wait. Where is our expansion port here? Game cartridge. External ROM. Or go old school, yeah. External ROM. I forgot how that was. External ROM high, depending on status of. We always want to. Yeah, but we need to set it in write state. So our chips hey Coolpad. The issue is I want to switch, like I want to tell the microcontroller that it should not overwrite its memory. Not even a megahertz system clock. How do we go? It's a 2 megahertz clock. Because we have like that's like it's communicating with the VIC, so it's 2 megahertz, even though internally it's the CPU is only 1 megahertz, but it's, I mean, you have like the falling and rising edge. Do you need to? Yeah, so more or less the VIC runs on the low edge, no, rising edge, falling edge, so it's sharing the same memory, but the CPU is basically freeing the memory on each, because like the VIC needs to read the memory to display the pixels, and it does it like every second edge, like the falling or rising edge, and the CPU is like freeing the address basically. So it only uses the address at the rising edge, and the VIC uses the address at the falling edge, something like that, or other way around. It was quite interesting. So actually nifty. Yeah, it works like it works actually on 2 megahertz. Or it just uses DDR, yeah, as you. Yes, every chip. So the chip, what does it need to know? It needs to know, first information is, do I read? Do I read? Do I write? Because in that case, so in this case, it's overwriting the internal memory on the address that we get. On this case, the enable is normally driven by the address bus memory mapping. Yes, but we don't have an extra pin. So is there a way of doing it without halving our memory space? Write means we pull down the data bus, pull down data. So we have only 2 bits to indicate, or in theory, we have 1 clock. That would be nice to know, because we want to know, all right, this is the time where we change it. Enable could be a combination of write and CLK. So this could be enable. In that case, the chip would be just waiting for the edge that's never coming. So it wrote every hex 13 address with odd or even values. So how to program in machine language. We need addressing logic on your PCB to enable the data bus transceiver to your chips. Yeah. So this would be a trick to only use 2 pins to basically internally use it as somewhat as an enable, because write needs to be high. Write needs to be high. We are writing to the memory, and clock needs to stay low. This would be the logic in that case. That means it's not enable, so this won't be enable. And if it's enable, then we get, if it's enabled, we have basically write and then regular clock. So we need like to make those signals hard-coded whenever it's not enabled by the address. Otherwise the address is like distributed amongst the chips. We are overthinking it, and you want an idea how to do it correctly. Addressing side of things, yeah. If we only map like 128 bytes to each chip, all right. Otherwise, then we can use like an extra pin. We have to rethink that. I need to check the specs. We certainly need 8 bits for the data, and will bus traffic use DMA? I hope. Oh. Oh. The VIC might do. You're correct. That's a correct input. So we have like to disable everything if DMA is going on, if DMA is used. Let me check that. We need to consider that certainly. Otherwise, we might like mess around with the data. There is no way of breaking it, because it's like what is open collector? DMA. What is DT4 programming guide? What is that? VIC sprites, that looks it. Using on initial boot both, the RISC are set to both read. Reading the bus is free, yes. It's VIC. That feels like it's a too hard project to start with, but it would be nice to have like something. C64 uses interrupts pin. I don't know if the hard drive might use the. pulse high and says hello and goes low reading the hello. Once the RISC sees it, go low and not high. Yes, the DMA is basically, we can use the DMA to control the bus ourselves. Oh, wait a second. We might be able to control the bus from this, from the RISC-V with the DMA. We just, whenever we enable the address, how do we do this? No. The C64 the C64, like if we don't want like to byte for byte communication, the C64 could tell the RISC, oh yeah, I want to access this part, like this RISC-V, so RV. I want to access this RISC-V, this one to Blinky, yeah, and this would copy, like fill dual port RAM. Yes. Oh yes, we can do that. I have dual port RAM here. Why do we do it so overcomplicated? Use dual port RAM. No, is it the dual? Is this dual port RAM? No. Yeah, it might. No, wait. Do we use dual port RAM? No, is this dual port RAM? VRAM, yes. Wait. Way many more pins. Okay, that's not dual port then. That's basic SRAM. That's SRAM, win bond. Yeah, because you need like the address and twice the. So dual port would be way easier of communicating, so we don't have the hassle with getting the timings right. We put like dual port DP RAM, but do we have one? No, we have two addresses, or yeah. So address, and data, DA. Like that. This is our interface. You can test. Oh wait, this is 0. Sorry. This is C64 and this cutting edge. Nine V plus and 5. Okay, so this would be the interface. And whatever we do here, it's just handled in the memory. Let's check Reichelt for dual port now. Oh, E. DDR, no. SRAM. Oh shit, it's hard. DPRAM. The DAG? 460. Nice. So I will put it in my basket as well. Can you give me the link on Discord? That would be nice. RP2040. Oh, actually, that's not a bad idea. It's fast enough. Is RP2040 5 volts compatible? Like if you like supply power is 3.3 volts, does it also take 5 volt signals in, or does it die? That would be nice to use it as an interface as well. Thank you for the deck. Yeah, I think I have buffers. I bought the buffers. There should be somewhere here around. Speicherausführung. Low power, type, static, SRAM. There is no... Maybe special ones? What is this? Sneaky. How do we get... Oh no, I want the chip. Hey, Artem. What is this? Switchable dual synchronous banks. Address decode. Bank decode. Going well. I/O control. A block diagram. Okay, let me check datasheet. Don't know what it asked. Yikes! Ugh. Okay. That's a lot. IOLR. Oh shit. Is this 32-bit or what? Definitely needs X-ray. Yeah, address is like bank code. Oh, that's 12-bit address. Yeah, look at that. I/O control. 32.6. That's like 32 plus some extra parity bits, is it? What the F is that? Yeah, I need something simpler. I need something simpler. Bank switchable dual port, multi-port memory. Maybe start with that. 16. Is there an 8-bit? Dual port RAM here. 8K. 8 dual port RAM. Perfect. This is what we need. That's looks manageable. Bus. What is the busy? Busy, not busy Y. It's busy. L busy R. Address decoder, 14-bit address. Output enable, whatever enable, arbitration, interrupt, semaphoric logic. Okay. Wow, it has everything. That looks alright. That's like a chip that could be. Is this QFN? No. This is PLCC. This is like, I see like bridges everywhere. No VRAM? What is no VRAM? Huh? What is, why? That looks like it's complicated. This is like relation status complicated. If we have like to convert C64 bus stuff to these timings. PLCC is SMD kind package with socket. Okay. Spaceship to chips. Okay. Yeah. No, RP2040 might be better choice here. Buffer chip. Are buffer chips even tri-state? What is this? Commodore Pico? Oh, yeah. We might have even looked at that before. Can't tell. That is the buffer logic for the pins. two address things and one data buffer. So the interesting thing is firmware. Wow. Use all available address space. Could this work? ROM and IO ports. Maybe designers already using GPIOs of the Pico. Yeah, that's the issue again. How many pins does the Pico have? Oh, SMT, yeah. Thanks. Okay, from high-low. Oh wow, that's a lot of communication again. BSD3, the cross license. Yeah, it seems Pico still has like issues with pin count, so we could also use like S2 or S3, ESP S3. I'm just wondering, like the buffer chip. Oh yeah, what I missed is what chips I use there. Buffer chips, because I'm wondering how the buffer chips are converting the how do they convert the open collector logic? How does that work? Schematic, let me check that. SN74 low voltage 244 P. That's what they used. Let's go to Texas. Bitluni blades. Yeah. Yeah, actually. Where's the datasheet? Yeah, I don't need a large address window. We can always use like 27 bits. I don't know what the ROM thing is. What's the size of the ROM window? I think I'm overthinking right now. You just want to solve everything at once We could just start and make the project bigger and bigger and bigger and get it. Where's the ROM? ROM low, signal range, external ROM. Here. Feature creep, yeah. So let's just start with 1 RISC or 2 RISC or 3 or 4 or 7. We have like only address. What's this address? This is like hex 2000. What's hex 2000? How much is this in decimal? $8K. Okay. So theoretically, $8K. If we would use, okay, let's calculate. How much power do we have? Do we need external power? So 8K is wait. Yeah. So plus bus IO. Yeah. So address pins. If we have 7 address pins, because we need like 3 IO pins with clock, read, write, and enable. So then it's 13. 8K is 13. Yeah, 120. That would be it. Seven address pins. What we have is then 6 bits for addressing the cluster MCU. So the solution is we don't use like 256 bytes windows. We are using a cluster of 64 MCUs times 128 byte windows, 8K. And we can just map every single MCU there. What do you think? Is this all right? But we need to demultiplex 64 64 addresses. Okay, let's do it. Let's do the design and then we will be done for today. Okay, we have C64. Boop, boop, boop. Here is a joystick for good measure. Okay, then we have the extension port. Boop, boop. Okay, then we have the card. The card. Let's draw it like that. On this card, We have 4 extension ports. Oh, we draw them smaller. With cards of 16 each. If we don't get like good ports to share that, but we have like shared, we can use small, that's all right, that will fit. Because we share all the data pins. So 16 times 4 times 4 times equals wait, 128 equals 8K. Machine code 8K for loop with a read-write action. What do you think? So, we need a design for this. And a design for this. It might, yeah, it will be on Wednesday, okay? Goodbye, Tech. I might want to design it first and already order some so we have something to play around. Otherwise, we will design it next round. Like I have still 15 minutes left for this stream, but that looks like a good idea. And we can use like a different. Okay, this design is basically for one type of card with shared address and memory. So we need this card. So this is let's extend this. Whoop! This is perfect. Infinite drawing space. My Windows 95 computer would die already because it needs too much RAM to store this bitmap. So this card, what kind of interface does it need? Okay, on this side, it needs, do we demux on the card or here on the base? Upsala. Need to extend it more so we can scroll. No, it doesn't. I don't think so. It does autosave. I like this card to be clean, so I might not like to multiplex it though. So keep it simple. Keep this one simple so we can reuse it. So we have shared data, 8 times data. We have eight times bank switch, yeah. Good night, Adam. That's not address. Oh, I don't like it though. A-time enable. No, 16 times enable. It would be nice to have the multiplexer, the multiplexer here. So because we have 16, that's like 16 enables. That's already quite a lot of pins. If we would do like 4, that would be way better. And Dmax on this board here. And then we have both logic. No, wait, we have data. That's like 7-bit. No, wait, 7-bit address. Can we do it more generic and like let the mainboard do PLD logic? What is PLD? PLD. Programmable logic device. Oh yeah, like yeah. Yeah, but you can just do more demux. Would each slot have a slot enable pin? That would be interesting. Oh yeah, that would be. Oh yes, that would be like +1, 4 plus 1. You are right. So this must be 5 then. Address, and then we have power. Power pins as well. And both logic. Both logic is like 2. Read-write clock. But I don't know about DMA actually. DMA needs to be handled by the main board. I don't like that it's already so many pins here. If we do like 16, we could do like 16 pin, 16 slots. So we have 8 data, 16 enables. Oh no, 7 addresses already too many. What's the regular card? What's the regular extension card? Pin count. Ah, damn it. Where is it? It's 44. Yeah. It's 44 pins. So it's even more, so I don't mind it. What kind of connectors do I have? That's like the 50 pins thing. Edge board connector. I would do let's say we do 20 pin. Oh, there is SMD ones. 0.8. How does that look? Oh, that's sweet. Look at that. That's SMD. they have it on stock? 3. Nah. Is this some PCI Express thing? Three remaining, one remaining, one remaining. Ah, man. Apply. Yeah. Wait. Huh? 20 pins. Is this 20 pins total? No, wait, we need 20 pins each side. Sorry. Sorry, my wrong. PCI Express. Yeah, but isn't that keyed? Like the short ones? Ether slot, yes. PCIe slot sizes. I don't want key. Yeah, they are always keyed. Look at that. They have always a key. Maybe it's not a bad thing to have a key there. So this would be the smallest size. PCI Express. Oh wait, we can check. What's the pin pitch? Halfling loaf slim. Doesn't say how many pins. Okay, key notch description. Key notch, and that's four times. Key notch, then we have a ground. So it's 32 pins, which is not enough. Times 1 pin at, oh yeah, no, times 1 is only, it's 18. That's not enough. That's not enough. SM clock data 36. So let's get back to check our idea. That might be enough actually. If we do the demultiplexing somewhere else, this would be enough. So we have that's 731 plus 2 bits 33, and then we have, is the position like 18? Is this already key notch? No, key notch is not measured like in pin counts or whatever. So we have quite a lot of stuff that we can put on the card, like I mean, except like power and grounds and maybe other stuff. Worth considering. Now let's check the logic here. What do we have? So reset that. Let's go 636. And what's PCI? Is this 36? No, 18, 36. Yeah, that's 36 pin. Let's see. Apply. That's not PCI Express. This isn't either. Huh? At least this one is easier to plug in. How big is it? 5 centimeters. Also a cute size, like that. That might be the right thing to pick here. It's €1 each. Where do I have PCI Express? PCI. There is an extra category for that. PCI results, PCI Express connector. 36 pin. Apply. Wow, okay, that's different prices already. Nice, 1mm pin pitch. Cool. Okay, let's see plug-in type. Wait, plug-in SMD. I want push-pull plug-in. What is this? Oh, why? Reset. Apply. Let's not do it. Huh? Okay. I like something simple that I can not plug in. What is this? Oh, that's side. Oh, that you plug it in on the side of the board. Interesting. Oh yeah, that's SMD. SMD mounted. I don't want SMD. I want certainly through hole. Let's sort by price. Probably. Yeah, this is it. This is not. Oh, they're alternating. We have like 4 rows. Interesting. You have 4 rows of pins there. That's easier to route as well. Look at that. Oh, that's almost Imperial. No, wait. 1 to 7. Huh? No, that's wrong. 1 to 7 half of. That's alright. I mean, it's. But why do we have disconnect on that side? What does that mean? I mean this plastic here. What does that mean? Millimeter step, yeah. But why do we have this extra? What is this, like a part of the standard? Yeah, that's pre-order. No, they have all this noses on the side here. I like that. It's cheap, it's easier to acquire. What's the size? Carry the 5 kilograms. But I mean, how does the nose here? How does the nose carry anything? What does that do? Is this like a retention thing, or what is that for? Did I miss anything? 5 kilogram GPU on PCI Express ×1. Look at that. They have also these noses here. Why? Yeah. This one doesn't. This one does it. And this isn't. Oh, this is an ESA port. Is it? No, something else, because the key is on the other side. Or we don't see the noses because it's flipped. Oh, that's PCI. Does PCI have same pin pitch? No. Wait a second. That PCI Express. PCI Express times. Oh yeah, wait. can we reset that and do, oh, micro PCI Express. What is that? Entry, oh, 120 pins. Okay. No. What does that? Interesting. Okay, so it is PCI Express times 1. That's it. I don't know why it is this. Why there is this nose. Should we ask ChatGPT? Oh, come on, I didn't log out. Retention clip compatibility, contact alignment. No, wait, this is something else. Keying orientation, mechanical stability. No, wait. These are not the noses that I was talking about. Yes. Plastic slots, retention clip blocking me. What size? Locking clips. No, this is not the side thing. Yeah, I just have to live with that. 38 cents per piece. Okay. How do we demux? Demultiplexer. So we will do the research and the design next time. Oh, we have already 10 o'clock. Dremel. CNC. I will just put in the finished card and let the CNC shave off every access pad. Wait. Edge connector. Now we have plenty of edge connectors here. Okay, let's do demux. Decoders. It's called decoders. CD. How many? 4 and then 16, and we have we need another one with 2 to 4 because we have 4 cards, 16 chips. So this one would be all right already. Nice. That's the one. That's the one. It's so strange. I'm wondering if we can use the... Yeah, that would be harder to maintain. Like the programming pin, using the programming pin as the enable pin, so we would be able to do a simple programmer that can basically... No, wait. Yes. Having that each programming pin... What is the programming pin of the CH thing? Programming pin is D1, I believe. Yeah. Shit, why didn't they put it on D0? Would be way easier. Using D0 as the programming pin. Otherwise we have like to shift around to do all the stuff. Like do 2 operations instead of 1 operation by rolling or whatever. I'm not sure. We still need to program them, so peeps. I need like an interface, like another card where we can just address it. Some card has template for boards. Ah, yeah. Oh, yeah, true. True. Yeah, we can use PCI Express template. That would be cool. Data. $128, or we do 128 MCUs with... It seems so. I don't know. I don't hear it. M2s. Oh yeah, M.2 sockets. I can't hear it anymore. 4-hour mark. We passed the 4-hour mark and I missed everything. But M.2 slots are always horizontal and I need vertical. Is there an M.2 slot? Mainboard has a VMPCI Express. How many pins does that have? But it will be hard to manufacture that. What's the PCI Express board thickness? 1.6? Cheapest with 2mm boards. No. Are you sure? That sucks. Yeah. Smart filtering in stock. 40. What is this shit stock? What is this? Hmm. Ah, yeah, I see that. That looks nice. Okay. So, what do we have here? How many? What's the logic? What's the highest stock number? 16,000. What's the count? 3 to 8. No good. Do we have like, I mean, if it's cheaper then how do I 4 to 16? One remaining. 506 in stock. 42. Wow. Again, we can save some space here. Four to 16 and then enable. What is this? A E is enable, or what is that? Enable input, active low. Why do we have two? Huh? Okay, let's see. Enable high, high. Only if both enables are low, that's cool. Truth table, yeah. So only if both are low, it's enabled. So do we need to invert it? I hope not. I mean, we can always do the logic of enable different way around. 4 two enable pins. So all go into there, and from there, each decoder gets an enable, and then we have a general enable. It's even cool that we have two enables there. So main design. I will just draw it out. Okay, we can keep the 16 here. The main card has some like 2 to 4 logic. So we take two addresses and do this is the level of 4 to 16. If we wanted to do it like that, we can put it also on the card, so that wouldn't be like change. And then we have each port. And here we have some level shifting as well. So let's see, this is the card. This is level shifting. Some level shifting. However that works. You see that 1.57 according to Google. Okay, I can't hear the chat anymore. What is happening there? It's completely dead. Bitluni dead, or? I'm so sorry. Everything indicates I need to tie to ground. Ah, now I can hear it. Okay. Yeah, so this is level. And then we have also, oh yeah, we need also level for some logic. So this is both bus logic, and bus logic goes boop. And also we have the data. This is the address. Address is basically some bus logic is going in there in the enable pins. So we need to, need to scroll to the side. You can see everything. So some bus logic is going in there. As well, some addresses go there. Oops, and the rest of the addresses go there. So this address go there, and some of the addresses go there. So it will be a mess. I'm not sure if I want to optimize to be able to program it easier, or if I do like a pogo pin programmer portal on the back of the card. Some sort of what would be the easiest way to program the pins? Again, PCI Express. Can I simulate with deeds? What do I simulate with deeds? I really love that MCU. Yeah, that's what we would use again, like this one. The great, almighty, super tiny, easy EDA PCIe times 1. Okay, we can ignore those. Yeah, I know, whatever. Library. Wait, huh? How do I clone that? Is this a part editor? Is this my... Huh? How do I... Oh, yeah, wait. Can I, huh? Can I add this? Wait, can I select it? Is this like a part editor? No, wait, come on. I don't want a part editor, I want to add. Is this like a part editor now? Wait, where am I? How does it look? Supercluster, let me close that. Let me close everything. Is this a part? I didn't use for my excuse. I didn't use Easy Day for ages. I have no clue. No, this is. I think this is the part editor. Wait. Let me file. Open new. Okay. New project. Super cluster 3. Okay, let's add. How do I add this then? Library, let's do PCI Express. Yeah, but system user contributed workspace as no. Oh wait. Huh? Footprint. Oh, interesting. I can rename that one. Okay, so this is the super thing. Then we add workspace. Then we do. I'm wondering if my JLC parts are here somewhere. Oh, where is the edge connector? Wait, the one that we found. Can we use the LC? That would be the other part. We can do CH32V. Alrighty. Yikes. How do we do this? How does the bus work? Okay, this would be data. C will be data for sure. Huh? How does that work with the how does the bus work? Does anyone know? Because I want to connect all the bus things. I would do the data one side, addresses on the other side, logic and so on. Wrong grid space. It doesn't look like wrong grid space. I mean, how do I add address lines? Do I just connect them like that? D. And then they will be all named the same or what? PC. Yeah. Yes. Yes, Fu. That would be cool. Is this now the bus? How do I bus it? The bus. How do I assign it? How do I assign the bus lines? Find. I never used the bus before. They're not even. Yeah, this is data that would be shared. Net port. I can also net port it. I don't care. Oh wait, this is D0. Design bus at. Oh wait, add lines. Okay, okay. Design bus line. Okay, so let's do. Like that. This is the bus line. What? Do you end this? Oh, aye. Okay, and then add single lines. Like that. Hey, Carp. You just connect them from different places to one dot. Oh, you're lurker. You're welcome to the chat. I connect them to the same spot from different places. So I need to do it. Wait. Here. Like this? That hurts, huh? Let's continue. Ouch. Ouch. Oh, this even hurts more. Wait, this is wrong. Foo. Oh, I hate this. I will just go with the net labels. I hate this already. Let me do the net labels. Yeah. I'm just hooked. Huh? Bus entry. Oh wait, it did D2. Now it does D2. Oh wait. Let's start with D0. Now I do next. Oh yeah, that works. Nice. Okay. D3. That is easier. 3, 4, 5, 6, 7. And then we have, unfortunately, the programming pin is D1. So I don't know the addresses, the address lines. Either we can use. No, that would be shitty. Just ignoring the first bit. It's so much calculation time. We need like 3 operations to move it. So I will use D0. So this will be A0. D1, D2, D3. Oh no, we need to make it separate. We can't short them. So actually that needs to be at the enable pin. Okay. It needs to be enable pin because otherwise it's always shorted. Oh fuck. Yeah. Tico time. Shit, what is 5? 5 is 6. Yeah, 7. Whatever. Okay, A4 is... Oh. We need to do the extra work, not overthinking. A3, no, A5. This needs to be A4. A2. A1. Wait, no, this is 0. Where's 0? Shit. Here. There's 0. Oh no, that's alright. PD. This is enable. Wait. No. Yes. This is alright. Now we need an enable pin. So because this is also PD1 is also the programming pin. So PD1 is SWIO. It's not here. It's not even mentioned here. Yeah, it's here. Okay, it's pin 15. This needs to be the enable pin because oh no, wait. Shit. Huh? Huh? I don't get it. Why is it? Okay. KaiCat, yeah, I totally get you. Then we have the enable. Then we have it's astonishing. I don't get it either. And this is read write. Okay, now we copy that and use just the enable thing. Can we do it like a sub thing, or do we just copy paste everything just 100 million times? It would be terrible to do that like that. You can buy the programmer on AliExpress. Yes, I have the programmer. Who someone was asking? Oh yeah, sorry, Mikael. How do you program this RISC-V course? Toolchain IDE. Yeah, so basically there is this, you can use a toolchain, Charles's toolchain to program them. Or you need like this a simple one-wire programmer. It supports like the Linky. I have it here to show you. The Linky has basically a two-wire or one-wire interface to program the WCH thingies, and you can use an open toolchain by Charles, or you can use the IDE that they provide for free to program it with firmware. So I will use there is no reset. The reset is basically, you can ignore it, and can power cycle it into programming mode in the first milliseconds, depending on the flags there. And D1 is basically the programming pin. So that's why we use it as an enable pin as well. So the other one can be connected. I did it before to have the D1 connected and program them at once, but somehow that changed with new versions of the programmer and whatnot, that it doesn't work properly anymore. So we have to have an individual pin for each of the MCUs without that being shared with the other ones. So we can now just take that and basically clone it, and we will just change that and be very annoyed. Ah! Okay, I'm used to KiCad, peeps. I'm used to KiCad. This is terrible. What did I do? Why did I? Oh yeah, that's another ground pin. Wait. Foo. Why? Why does it do it to me? Or we just leave it, remove that, copy that, and add the label now, enable to, yeah, that will be the best. Just enable and will increase. And yeah, let's just add the they have no LEDs, peeps. Yeah, we need to do a sub-circuit for that, because there is no caps and no LEDs. We can do like caps extra. Oh, that's shifted by 1 square. Okay, here. Like that. And now we can number it 3, 4, 5, 6, 7, 8. Oh, it got the 0. That's smart. The label increase thingy. Okay, and we need how do I shift it? Like this, okay. That feature that I find annoying in KiCad, I just try to use it on JC easy day, and okay, here we go. Let's leave it here. Or we can resize that. Can we resize that? No, that doesn't resize. Yeah, what do we do here? Wait. We have like, we forgot that we need... Oh wait, that's pin 21. We don't need to wire that. We can wire it. I forgot to add this pin. It's basically the ground pad. There is no... It might get more difficult if we want to wire that. Oh, importing it? Does it support like a complete... They like that they have... What I like, they have some libraries for that stuff that is compatible with the manufacturing there. So they might actually give me a proper connector for the PCI Express that really fits. So PCI Express is 2 millimeters for sure. Is everyone... Because then our boards get more expensive. Might get more expensive. All right, so now we need to copy everything here and add it to the connector. Aye. Do we have even enough pins here? Let's see. This is 7, this is 7. Where do we put the data lines? Oops, okay. Huh? B1. Yeah, I don't care about that. X. Y. Let's just put it there. We just want to experiment a little bit. We need some enable pins. Oh, where's A0 here? Y. Let's put it here. We can put some ground stuff. I hate this, the labeling here. Can I edit this? Edit 9. Edit symbol. Can I edit it in the... Edit in the library? Because it now overlaps here. Clock ground. Let's put it here. I don't care. And we have 16 enables. Oh shit, this is quite close. Clock ground. Wait, we can do this on this side. No, 7. Still not good. Okay, let's clock it then. Let's write it. Then we have let's start with that again. And wait. Put it here. Let's add this. That's the 15. Oh wow, we don't have a lot of power going on. Shit. One power pin. Yikes. That will be glowing. At least we don't have LEDs to power with that. Yeah, let's check. Let's check the data sheet. Specs, no. What are the electrical characteristics? Okay, that's I/O. I don't care about I/O. How much current does it? High speed internal milliamps. What is this? All peripherals are labeled, all peripherals disabled. So it's like 6 milliamps. External clock, internal doesn't really matter. Let's say 7 milliamps times 7 times 16. That's like 100 milliamps. 150 milliamps. That's good enough. We can do that. 150 milliamps on one pin. What's the spec for MPCI Express? On one pin. PCI Express Edge Connector, where is it? Let's see. Let's check that one. Max ratings. Does it say anything? No, it's that. Yeah. Yeah, but that's they have more power lines. ground pins 5, 25 watts, that's 5 watts. That's, yeah, that should be alright. That would be 1 amp per pin, more or less, at 5 volts. But it uses 12 volt pins. So the watts is like 500. Wait, what are you doing? 2 amps, 400 milliamps per pin. All right, then we are fine. We can just run with 3.3 volt. That's more important to have than 3 GND. Okay, then it's all right. Oops, what is this? Oh wait, is this the bus? Oh, that's the bus entry. Okay. Now I get it. That's what you meant. All right, we are fine. What is this? Pin. Yeah, nice pin. Thank you, bro. Yeah, let's save it. And we will add some caps later. Caps will be necessary because of the thin power line. And then where is the design? PCB. Yes, check nets, whatever. What is this? Huh? Wait, what? Oh no. Are you kidding me? Is this how it works? Wait. Oh, okay. Actually, it does work like that. It's so strange. Why? Everyone cringes who watches this video. All right. So now we have, okay, we have some whatever. Yeah, but I need to ignore it. No, keep going. Okay. Yeah, whatever. Wait, what's going on? What issue does it have? Do I need to rename the pins or what? Wait, what? What is going on? Fool. Huh? Now it's shrinking? Now it's a smaller footprint? Okay, I give up. Huh? What happened? Huh? Oh, now I need to flip this again. Oh man, this is terrible. A good experience. Can't select it anymore. More or less here. Now I move that on that. Yeah. Okay, now it's spot on. How do design perfect, perfect. Keep on going. Can't do it. All right, peeps. I will try. Oh, wait, how do I? What happens if I do that? Does it keep going, or is just my footprint broken? No, that's broken footprint. I don't know why though. There is no footprint whatsoever. Oh yeah, here we go. Guest blah blah blah. User contributed. Wait, what? This will not work, will it? Annoying. Oh, now it worked. Okay, so now let's update it again. I had something bad going on with my footprint that I saved. Maybe I destroyed it. So how do I update it? Import changes. Let's snap to grid. Snap to. Oh, it didn't use it for ages. Snap locked. Board outline. Routing as snap size. 5 mil is snap size. Yeah. So in the end, and it will look like this. Maybe we will do it in KiCad because it's quite annoying. I can find a footprint for a PCI Express thing here. Is this the outline even? Board outline? Yeah, it is board outline. I'm wondering, wait. If I need to cover it like that, I need to find out, peeps. And then make the board like that. And move them all in here. Like that. and then wire them and do a 5mm board. They will fit on the small PCI Express footprint. Do you like it? I can't hear you. Sorry. Or you're not saying anything. Speechless. First time ever like that. Perfect. I'm back. Okay. Yeah, it will totally fit on the board. This will be really cute, like a RAM slot. Look at that. Cutie. Cutie, cutie. You can make it even smaller. Abstract art, yes. Maybe, please, AI root. Yeah, let's do it. Outer root. Save. And then root, outer root. Run. Outer root to server error. Locally unavailable. Cloud. Yeah. Okay, it doesn't work. Okay, let's design this next time on Wednesday, peeps. We have a challenge. We will do a supercluster, or I switch to an M3 slot. Good night, everyone. Bye bye. Thank you for joining, and yeah, we even had like a 4-hour stream. Bye bye, everyone. Good night. Is there a raid to do? I don't know. Good night, David. Good night, Sonic. I'll try to raid, maybe. Good night, Fenua. Oh, we will take care of a raid next time. I'm just done. Ha! Done for today.